Ukraine introduces Trident, the future of laser warfare. Laser weapons, which belong to the category of directed energy weapons, are becoming more advanced in modern warfare. These weapons include lasers, microwave, plasma, and sonic devices. Lasers generate an electromagnetic beam through a process called stimulated emission, resulting in a beam with low divergence. In just a brief moment, lasers can emit a beam traveling at the speed of light, offering impressive accuracy for military use. Lasers have been used by the military for many years, primarily for targeting purposes or measuring the distance to a target through laser rangefinders. Today, advanced laser devices with power outputs of several kilowatts or more have made it possible to create laser cannons. These laser systems can effectively disable an enemy's optical equipment and, with higher power versions, can destroy lighter targets such as drones. As technology continues to improve, lasers are expected to engage more challenging targets, such as aircraft or light vehicles. One of the key advantages of laser weaponry is its precision. Once the target is within range and the fire control system is functioning properly, lasers provide near-perfect accuracy. Additionally, firing a laser is incredibly cost-effective. A single shot from a laser can cost as little as several dozen to several hundred Canadian dollars, while a medium-caliber artillery shell may cost hundreds or even thousands of dollars. Rocket munitions, on the other hand, can cost hundreds of thousands or even millions of dollars. For example, a drone costing several $1,000s would be economically defeated by a relatively inexpensive laser shot. However, lasers are still in development and are affected by weather conditions, which can limit their effective range. They cannot bypass terrain obstacles, and firing them requires significant amounts of energy, which is a challenge for the technology. Despite these obstacles, ongoing research is making lasers more feasible for military applications. Recently, the armed forces of Ukraine introduced their indigenous Trident system. This system is designed to counter low-flying targets, including flying bombs, drones, and other aerial threats. Colonel Vadim Sakharevsky, who is in charge of drone units in the Ukrainian army, provided some details about the system. While the Trident was revealed in December of the previous year and has reportedly been used in combat, it remains unclear if it is the sole prototype or if there are other units in development. Furthermore, it is still uncertain if the Trident is entirely Ukrainian-made. Using lasers as weapons isn't a new concept. In fact, early examples include the Soviet mobile system 1K-17 and the American airborne YAL-1 system. Today's lasers are far more advanced compared to these early models and even those portrayed in popular media. Laser systems now resemble optoelectronic heads or anti-aircraft searchlights, making them more practical than visually striking. Countries worldwide are now investing in laser cannons. These systems range from lasers with power outputs of several kilowatts to those with hundreds of kilowatts. Lasers are expected to play a significant defensive role in the future, specifically for neutralizing threats such as rockets, drones, and artillery shells. Initially, lasers will likely replace low-caliber cannons, which are less effective and costly. A prominent focus for the development of laser systems is their installation on ships. Naval platforms offer substantial space and energy reserves, making them ideal for laser integration. One well-known program is the British Dragonfire, developed by MBDA UK, Leonardo, and Kinetic under the guidance of the UK government's DSTL Centre. The Dragonfire laser system has been tested for years and is capable of tracking and hitting an object the size of a 1-pound coin from a distance of about 1 kilometer. The cost of firing a 10-second shot is estimated at just £10. This system is designed for use on Type 45 destroyers as well as other UK naval vessels, including frigates. In Germany, another laser system was tested on a Sachsen-class frigate. Developed by MBDA Deutschland and Rheinmetall Waffenmunition, the system successfully neutralized aerodynamic targets in tests conducted in 2022 and 2023. Meanwhile, the United States Navy has been progressing with the Helios program, aiming to develop a laser with power up to 150 kilowatts, with plans to push the system's output even higher in the future. On land, the U.S. is advancing in laser defense technologies as well. In 2024, the U.S. successfully tested a 50 kilowatts laser system mounted on a Stryker vehicle, along with a lighter, 20 kilowatts version known as PL. These systems aim to provide effective self-defense against aerial threats. In the future, the U.S. plans to develop lasers capable of destroying targets from up to 10 kilometers away. Other nations, like China and Israel, are also pushing forward with laser defense systems. China is working on the Laser Arrow system, mounted on a 6x6 tactical vehicle, while Israel's Iron Beam system is designed to intercept missiles with a power output of up to 300 kilowatts. The development of these systems has gained momentum, especially with ongoing conflicts, such as those in Gaza. Lasers are also expected to play a crucial role in airborne defense. They could be mounted on unmanned aerial vehicles such as MQ-9 Reaper drones to neutralize enemy missiles or drones. Additionally, some experts believe lasers could serve as active protection systems for 5th and 6th generation fighter jets, designed to destroy incoming anti-aircraft missiles.